Chapter 3.6 Exponents, Complex Fractions, and the Order of Operations Agreement. Okay, first of all, let's say let's have exponential form. This is 3 to the 5th power. 3 to the 5th power. This is how we read. And the exponent 3. The exponent indicates the repeated multiplication of the same factor, which means the exponent is 5, so the base 3, because base is 3, so the base 3 is multiplied 5 times. 1, 2, 3, 4, 5. So the exponential form indicates the exponent 5 means the base 3 is multiplied 5 times. So this is a product, and the base 3 is a factor of this product. So you have a product, then each number in each part is called a factor. So 3 is a factor. So there are 5 factors of 3, right? 3. So the exponent 5 indicates how many times the base 3 occurs as a factor in the multiplication. So this is a multiplication. This is a multiplication, and each number 3 is a factor. So 3 occurs 5 times. Why 5 times? Because the exponent is 5. Alright, so let me write it here. So 3 to the 5th power. This means the exponent, 5 is called what? Exponent, right? Exponent. And the one just below this 5 is called the base. Base. So the base 3 is multiplied how many times? 5 times. Now let's evaluate this exponential expression. Now look at this. 4 is an exponent. Then the base is the one inside the parenthesis. This is really important. If base is just a number, if it's not a just number, then put parenthesis. So it is safe. So which means like a 2 to the 4th power. Then the base will be, the base is what? The base is 2. How about negative 2 to the 4th power? Then what is the base of this one? The base is 2, not negative 2. If you want to make the negative 2 the base, then you have to put parenthesis. Then the base is what? Negative 2. Make sense? So if there's a parenthesis, then everything inside the parenthesis is the base. So we're going to multiply 2/3, the base 2/3. How many times? 4 times, because the exponent is 4. So multiply 4 times. So 2/3, 2/3, 2/3, and 2/3. So this is a product. This is a product. So you can multiply everything in the numerator, and then over multiply everything in the denominator. Right? So 2 to the 4th power. This is 2 times 2 times 2 times 2, which is 4, 4, 8, 16, right? 16. And 3 times 3 is 9. 3 times 3 is 9. So 9 times 9 is 81. This is how we evaluate an exponential expression. Now evaluate this expression. This is a product of 2 exponential forms. So the first exponential form is, we can write a product of the base. The base is negative 3 over 5 2 times, right? So we're going to write each factor as many as indicated by the exponent. So the base is negative 3/5, so negative 3 over 5. So this will be multiplied how many times? 2 times, because the exponent is 2. How about the second exponential form, this one? This is a cube, right? Cubed. So we're going to multiply the base 5 over 6. How many times? 3 times. So write the base as many times as indicated by the exponent. So 5 over 6 times 5 over 6 times 5 over 6. Okay, then negative becomes positive, so you can rewrite it as 3 over 5 times 3 over 5, right? And then the rest is the same. Okay, so this is all product, so you can multiply all the numerators together and the denominators together. 5 times 5, 6 times 6 times 6. Okay, then what do? You can cancel out the same common factors. So, this 5 cancel out. And this 5 cancel out. And 3 divided by 3 is 1. 6 divided by 3 is 2. And 3 divided by 3 is 1. 6 divided by 3 is 2. So the answer will be 5 over, the denominator is 2 times 2 is 4. 4 times 6 is 24. So this is the result of this expression. So what you do is, write the base, multiply the base how many times? The number of exponents. Okay, and then reduce the numerator and the denominator, then simplify. Okay, for this example, we will evaluate x squared times y squared for the given values. Alright, that means we're going to replace this variable x with the value. So x is 1.5. So why don't we convert this improper fraction? That is 3 over 2, right? So replace x with 3 over 2 and then y with 2/3. So when you replace it, okay, so here's x squared times y squared. So when you replace x and y, use the parentheses. Parentheses squared times y is 2/3 squared. Okay, use parentheses because if you don't use parentheses, what happens? 3 over 2, like x squared. Then 3 over 2 squared. So this looks like we're going to square only this 3, right? It looks like, 3 squared over 2, right? So this is different. So you have to put what? Parentheses. Because I'm going to multiply this x twice. Multiply this x twice. So put parentheses so that you can multiply this base twice. Okay. All right, then simplify. No, expand it, right? Expand it. So the base is 3/2. So multiply 3 over 2 2 times. And then the second exponential expression is 2/3 squared. So multiply 2/3 twice. Okay, then put the numerators together. This is our product. So 3 times 3 times 2 times 2. The denominator is 2 times 2 times 3 times 3. And then simplify. So you can get rid of 1, 3, and another 3, and then 2, 2. Okay, 2 and 2. So we have 1 over 1, right? 1 over 1 is equal to 1. Okay, now let's learn the definition of a complex fraction. Okay, a complex fraction is a fraction whose numerator or the denominator contains one or more fractions. So look at this. So okay, for example, okay, now here's a main fraction bar, and then the numerator is a fraction like 3 over 2, and denominator is also a fraction, something like this, 4 over 5, something like that. So the main fraction bar is always longer, okay, longer than other fractions, or something like this. Here is a main fraction bar, and let's say the denominator is 1 over 4, and the numerator is 3. Still, this is a complex fraction. And how about this? Okay, same thing. Okay, the numerator is 4 and the denominator is 3, but this is a subtraction 1 over like 2. So as you see this is the main fraction bar, but there is another fraction in the denominator or in the numerator, then it is a complex fraction. How about this? Here's the main fraction bar, and then 2/3 plus 1/4, and the denominator is 2 to the 5th power, 2/5. Okay, still there are fractions in the numerator or denominator, and or the denominator. Okay, how about this? Let's make it more complicated. So 3 and 1/2 times 2 and 5/8. And the bottom, the denominator contains 4 and 2/3, like divided by 3 and 1/5, something like this. So this is also a complex fraction. So complex fraction is either numerator or denominator or both has a fraction. Okay, if there is a fraction, a complex fraction, then we can read it as this. So 3 over 2. So the numerator, read the numerator, 3 over 2 divided by. So the main fraction bar can be read as divided by, okay, divided by 4/5. So we can write the expression, complex fraction like this, 3 over 2 divided by. So divide symbol and then the denominator, which is 4/5. So we can rewrite this as, so when we simplify the complex fraction, it looks like this. 3 over 2, the numerator is divided by the denominator, which is 4 over 5. So when you have a division, then what do? We can make it a product by switching the top and bottom, the numerator and denominator of the divisor, right? So it'll be 5 over 4. Okay, then you can multiply 3 and 5 in the numerator and over the denominator. So that is 15 over 8. Or you can write it as this is an improper fraction, so you can make it a mixed number. So 1 and 7/8, still okay, right? So when you have a division, this is the divided by, right? Divided by. So use the division symbol, and then convert it into multiplication, right? Multiplication by switching the numerator and denominator of the divisor. The fraction, right? Fraction. Okay, now let's simplify this complex fraction. Okay, when we simplify a complex fraction, unlike the previous one, the numerator is an addition. So first of all, we need to simplify the expression above the main fraction bar, and then the expression below the main fraction bar. Because the above the main fraction bar is an addition, right? So let's simplify the expression above first. Okay, then the denominator of this addition is different, so the LCD is 10. So this is equal to, the denominator is, the LCD is 10, so the numerator is unchanged, -9. And 5 became 10 by multiplying 5 by 2. So multiply the numerator 3 by 2, then that is 6. So this is equal to -9 minus 6 over 10, plus 6, sorry, plus 6 over 10. So the numerator is -3 over 10, right? Which is, you can move the negative sign to the front. So -3 over 10. So the equation, -9 over 10 plus 3 over 5 over 1 and 1/4 is equal to, So the numerator, the expression in the main fraction bar, above main fraction bar is negative 3 over 10, right? Over, okay, 1 and 1/4, we have to convert this one into improper fraction, so it will be 5 over 4. So since the main fraction bar indicates a division, so you can rewrite it. So negative 3 over 10 divided by 5 over 4. And next, you can convert the division into multiplication, so that you can switch the denominator, your fraction, so which is 4 over 5. So write the reciprocal of the divisor, 5 over 4 into 4 over 5. Then negative stays outside. 3 times 4, the denominator is 10 times 5. Can we reduce? Yes. So 4 and 10 can be divided by 2, right? So 4 divided by 2 is 2. 10 divided by 2 is 5. Then there's no common factors. So the answer will be negative 3 times 2 is 6 over 5. Or you can write it negative 1 and 1/5. Okay, now let's check if 2/3 a solution of this equation. So when we check, we have to replace this x, the variable x, with the given number 2/3. All right, so let me check. So let's check whether this is true, right? This is true. Let's check. So what we're gonna do is, okay, this is a fraction. So replace this x with what? Replace the x with the value 2/3. X is 2/3, and then this will be 1/2, right? I just replaced x with 2/3. And then let's calculate the bottom. Okay, so this will take more time. So the numerator, what's the numerator on the left hand side? The LCD is 6, right? 6. So this will be 6. The denominator is 6. So 3 times 2 is 6. So 2 times 2 is 4. And this one is 6. So 2 times 3. So 1 times 3 is 3. And denominator is the same. Okay, let's keep doing this. So this will be equal to 7 over 6, right? This is equal to 7 over 6 over, okay, why is it 7? Okay, let me write one more time. So this is 4 plus 3 over 6, right? Over 2/3. So the numerator is now 7 over 6 over 2/3. So since this is okay, we are wasting our space. So this is equal to 7 over 6 divided by, and then 2/3, right? Since this is division, okay, divided by 2/3. So you can change the division into product. Then this 2/3 becomes 3 over 2. All right. Then 7 times 3 over 6 times 2. And then reduce, right? Reduce. So 3 over 3 is 1. 6 over 3 is 2. So this is equal to 7 over 4. Okay, now let's check. Bring this one down. This is 7 over 4, right? 7 over 4. Okay, let me put it here. So this is equal to 7 over 4, right? So bring this one down, bring this down, bring it all the way down. So this is equal, right? Equal. So yes, the answer is yes. 7/4 is a solution of the equation. Okay, so what we did is just replace x with a given number and then check whether the left-hand side of the equation, the result, is the same as the one on the right. If they are the same, then yes, that value is the solution. Okay, now this is a really important definition, the order of operations agreement. Okay, when you have an expression to simplify, okay, we do steps. So step 1, 2, 3, and 4. This is really important steps. So the first step is do all operations inside parentheses. So if there is a parenthesis, then you have to simplify the expression inside the parenthesis first, always. Okay, and the second step is, so once you clear the expression inside the parenthesis, the next step is check if there is any exponential form. If there's an exponential form, then simplify that exponential form. Okay, that's the second step. And the third step is if an expression has division and multiplication together. So it's a product and or quotient together, then we will simplify from left to right. So if division comes first, then divide first. If a multiplication comes first, then multiply first. So we will do the division and multiplication or multiplication division as they occur from left to right. Okay, this is really important. So for example, let's say you have 2 times 3 times divided by, let's say, 4. Then what we do is do from left to right. How about this? 2 divided by 3 multiplied by 4. Then what do? You do it from left to right. The left to right as they occur. So multiplication, the first expression is what? Multiplication, division together, right? Together. So what we do is do it from left to right. Whether it's product or division, do it from left to right. How about this one? This is a division and multiplication, right? Division and a multiplication. So what do? Do it from left to right as they occur from left to right. Okay, this is really important. And the last step is do the addition and subtraction. No, we know how to do addition and subtraction, right? So do it from left to right, doesn't matter in this case. So how about the fraction? If there's a fraction bar, if it's a complex fraction, then I'll just assume this fraction bar as parentheses. So you do the numerator. So numerator is 1 parenthesis and denominator is 1 parenthesis. So the fraction bar acts like parentheses. So let's evaluate this one. Okay, w plus x divided by y and then minus z. So what we do is first replace all these variables with their values. So w is 3 over 4 plus x is 1/4 and the main fraction bar y is 2 and then the minus z. Z is 1/3. Okay, so the main fraction bar is this one. And the numerator. So numerator is one big parenthesis, right? 1 parenthesis. So simplify the numerator, then that is 4 over 4, which is 1, right? Which is 1. The 4 over 4, which is 1. The denominator is this. So this is equal to 1 over 2 minus 1/3. Then the denominator is 2 and 3, so the LCM of the denominator is 6. So 1 over 2 becomes 3 over 6, and 1/3 becomes 2 over 6. So this is equal to 3 minus 2 over 6, so 1 over 6. So we can simplify this expression like 1 over 6. Okay, so let's simplify this expression. Okay, first we need to do the parentheses. Is there any parentheses? Yes. Okay, look at this. This is an exponential form and the base is a parenthesis. But in this case, the base is a simple fraction. So in this case, this one is already simplified. So you don't have to worry about this. But look at this. This is a complex fraction, right? So you have a fraction. This is the main fraction bar. So as you see this, we can separate the numerator and denominator as one parenthesis. Even there's no parenthesis, the fraction bar works like, it acts like a fraction bar, right? So parenthesis, the fraction bar works like a parenthesis. So look at this. The order of operations is P parenthesis exponent, multiplication, division, and addition, subtraction. So you can write it something like this. PEMDAS. PEMDAS, or for the multiplication division, if division comes first, then we do it first. We do the division first, right? So PEMDAS or PEDMAS doesn't matter. If multiplication divisions are come together, then we have to do it from left to right. So division comes first, then do division first, and then multiplication comes first, and do the multiplication first. All right, so in this case, 7 minus 2 over 13 minus 4 should be done first. So we will simplify. Let's simplify 7 minus 2 over 13 minus 4 first. So that is equal to 5 over 9, right? 5 over 9. All right, so we can rewrite it. So let me rewrite it. So negative 2/3 squared stays, and this fraction became 5 over 9 minus 1/3, right? So that's the first step. And the next step is, okay, let's use PEMDAS, right? PEMDAS. So PEMDAS or what? Or PEDMAS, right? PEDMAS. Okay, so we have just cleared the parentheses, which is the fraction, and an exponent. Next step is the exponent. So we have an exponent here, 2, right? 2. So let's simplify this exponential form. Then that is, so next step is what? Simplify negative 2/3 squared. So that is negative 2/3 is multiplied 2 times. Then negative becomes positive. So this is 2 over 3 times 2 over 3, which is 4/3. Okay, so we can write it like this. So this exponential form became 4/3 divided by 5/9 minus 1/3. All right, and next one is we simplify this division, right? This division. So simplify the division. Then it will be 4/3 times 9 over 5 minus 1/3. And the division became a product. So let's simplify this product. Then we can simplify. So is it 4/3? So this is 4. I'm sorry. This is 4 over 9, isn't it? Made a mistake. This should be 4 over 9. The denominator, 3 times 3 is 9. This should be 9, right? 9. 9. And 9 and 9 cancel out. So it will be 4 over 5 minus 1/3. And finally, the denominator is 15. So 5 times 3 is 15. 4 times 3 is 12. And then 3 times 5 is 15. So the numerator is 1 times 5, which is 5. All right, then this is equal to 12 minus 5 is 7 over 15. So this is the answer. Okay, so each expression is different, but when you simplify it, what do we do first? Parentheses first. Simplify the inside the parentheses first, and then exponential form. Then what? Multiplication and division comes together, then do it from left to right, left to right. And then finally add and subtract. Alright, so that's it for this section.